So we'll start off the videos with the first one being on atomic structure, and we won't focus on electron configuration. We'll keep it to basically atoms and how we discovered that they have isotopes and how to find the average mass of the element from its isotopic masses, and also behavior of subatomic particles in an electric field. So we'll start off with that, just the idea, and I'm sure we can all see, basic things like, for example, if I were to share with you an element like this, this represents atomic number 19 and 39 represents your mass number. If this is for an isotope, there are isotopes like argons and calciums where you will even recognize that they have the same mass number. And so you can have atoms of different atoms of different elements that have this different number of protons but the same number of nucleons, which is also called mass number. So so that you know that exists. And also that's not just one thing. We can also recognize that from this information we can find out for each atom their proton number, their neutron number, and the electron number. And one thing, I'm sure everybody knows how to do this, but one thing people need to realize is that the reason why ions exist is the mismatch of the number of positive particles and the number of negative particles. And for that, you need to know that for protons, neutrons, and electrons, their charges, their relative charges. We won't worry about the exact charge, but the relative charge, and this is obvious knowledge from O levels, is that they're +1 and they are neutron is 0 and electron is -1, and their mass, relative mass, for a proton is not plus doesn't exist, 1, 1, and this negligible, not 0, negligible, but pretty small, yeah? And so the next thing we'll look at is how these guys are affected if they are passed at high speeds through electric field. So you need to know that, which will bend towards which pole or which electrode, and by what angle of deflection will they be, because the masses will come in handy. So let's look at that. So I'm going to shift to the next slide for that. All right. So on this slide we are going to discuss how these three particles, electrons, protons, and neutrons, are affected in an electric field. Now electrons are negative, so they'll move towards the positive plate. Neutrons are neutral, so they'll go straight through, and I'll draw them because they're not a problem, just going straight through. But protons are positive, so they'll be pulled towards the negative plate. So you think that electrons will go this way and protons will go this way. But if they were moving at the same speed, knowing that protons are much heavier than electrons, the deflection that protons will experience is definitely much less than that of an electron. So electron might experience that much more than what a proton might. Obviously, even lesser if you ask me, but towards the positive plate and towards the negative plate, because electrons are negative and protons are positive. So that's that. All right. Now, so that's one thing that you need to remember in A levels. The other thing you need to remember is how to read atoms, their isotopes, their isotopic abundance, and the finding out their average mass. Now, we start off with a concept that you might remember in O levels, which is, and that's on the next slide, the idea that we know from O levels that chlorine had two isotopes, एक का mass था 35 and the other's mass was 37. And we knew that the average mass, or the AR of Cl, was 35.5. And the reason for that is because of something we call relative abundance. And we knew that the abundance ratio between 35 and 75 in the real world was about 75% to 35%. Sorry, 25%. Or in some books we call it 3:1 ratio. That was the ratio of the abundance of the two isotopes of chlorine. And we'll talk about how we've got this. In A levels we know we get this through mass spectrometer. We just go that in the next slide. But if you know this, then finding out the average mass is easy, because all you got to do is you got to be able to find the AR, you got to be able to multiply the mass with its abundance. And in that case that was 35 and 37 times its abundance over total abundance. In this case, that would be 100, and this would result in about 35.5. That's the average mass of the chlorine elements found in naturally. Now, where we got these values from, that's the only part that's new here. That is the mass spectrometer. So let's go there. So I'm going to show you a mass spectrum, and we're going to dissect that to be able to find the atomic mass of atomic mass of elements. So let's look at this question. There's an element we do not know, and its mass spectrum is given below, which is the isotopic composition. A mass spectrum will be a graph. We'll have on the x-axis mass numbers, or also known as mass to charge ratios, and on the y-axis it'll have a relative abundance. Either it'll be in terms of ratio or in terms of percentages, but they'll be the same thing. So what this tells me in looking at this graph is that whatever element I had, it has two isotopes because there were only two peaks. One of those, so if you call the elements, let's say X, one of those will have a mass of 10 and the other one has a mass of 11. That's the mass numbers. And we've got to find the average mass of the element, and for that we will take their abundance into account. So the way we calculate this is, and I'll scroll up just a bit, is that the abundance for mass 10 is 1 and 11 is 4. So it'll be the average mass, the AR would be 10 into the abundance, which is 1, plus 11 into the abundance, which is relative, which is 4, over total abundance. That would be this value plus this value, 4 plus 1, which is 5. And this will result in, you add them up and you divide them by 5, you'll get 10.8. So this would tell me that the relative mass of this compound, this element is 10.8. Now, obviously, whatever, they can give you graphs with 3 values, 4 and 5 and 6 and so on, you know. Isotopes also. We'll take a look at that also. But we'll look at another question a little later. But the last kind of question, the last thing that we can take and expect us to is that if they would tell us, for example, that yeah, I've got copper has two isotopes. Let's say copper has two isotopes, 63 and 65. And they would tell you that the relative atomic mass of copper is 63.5. And they would ask you that, well, if I know these are the two isotopes, I want to know what their abundances are to get this particular atomic mass. So for that matter, if I assume that the total abundance is 100%, and if the abundance for 63's isotope, or copper 63 isotope is X, therefore the remaining abundance for the 65 one would be 100 minus X%, because the total has to be 100%. And having this simple math, what I realize is that I can just plug into the idea that the mass into the abundance, the mass into the abundance will give me the average mass. So 65 into 100 minus X. And that, the whole thing over total abundance, which is 100, this should equal to 63.5. And I know that, so I can just solve this for X. And what I do, when I solve the whole thing, I realize that in this particular case, X is coming out to 75%, which means that the abundance for the 63 isotope is 75%. So for the 65 would have to be 100 minus that, which is 25%. All right, and so you can work that out also.